Okay, let's take a look at another example. So this time we want to find the integral 6x plus 7 over x plus 2 squared. Now the difference between this example and the one we have over here is now this linear factor is a repeated linear factor. And when the factor is repeated, we gonna use we cannot do this way. We cannot let this be a over one factor plus b over another factor. Why? I can show you this. So say over here we have a 6x plus 7 over x plus 2 times another x plus 2, right? The factor is repeated twice. Now think about if you use this pattern. If you use this pattern, and then once you add the left side and the right hand side, what you will get? You will get a plus b over x plus 2, right? Because right now the denominator are the same, so you don't have to do anything. You can just add them directly. So therefore you can never compare. You can never compare this with this, right? So this is not the pattern we're going to use. When the factor is repeated, now the first fraction is a over this linear factor. Well, this doesn't change. Okay. Now the second fraction is b over x plus 2 squared. Is a b over this entire repeated factor. Right? So over here, to add up these two fractions, I need to multiply x plus 2 to the numerator and the denominator. And then I can add these two fractions together, and I have a x plus 2 plus b. Now at this point, I will be able to compare this with this, right? So from these two expressions, we can see 6x plus 7 must be equal to a x plus 2 plus b, and we use this to figure out a and b. Now let me use the second way to figure out a, b. So first, let's think about if we let x be negative 2, then we have over the left hand side we have a negative 12 plus 7 equals a times negative 2 plus 2 plus b. So we have negative 5 equals b. So b equals negative 5. Okay, we figure out b equals negative 5. And then to figure out a, because right now we know b is negative 5, so 6x plus 7 equals a x plus 2a minus 5. Okay, so therefore because on the right hand side we have a x, and on the left hand side we have a 6x, so a must be equal to 6, right? So a equals 6. So we can rewrite this rational expression into into 6 over. And another thing is once you plug in the numbers, these two numbers back into this equation, remember what does x stand for and what does b stand for, right? So a is the coefficient, a is over the x plus 2, so you should put 6. You should plug in 6 for a and plug in -5 for b. So my point is you don't want to mess up these two numbers, okay? And the second fraction is plus -5 over x plus 2 square. So now when you find this integral, it is equivalent to find the sum of these two integrals. Okay. Now, what if we have both non-repeated linear factor and repeated linear factor? So which pattern shall we use? So first, there are two linear factors. One is x plus 2, and this factor is not repeated. Another factor is x minus 1. Now this factor is repeated. So for this non-repeated factor, we use this pattern a over x plus 2, right? So there's one fraction. Now, for this repeated factor, we have another two fractions. One is b over x minus 1, and another one is c over x minus 1 square, right? Okay. Or let's look at another example. What if we have these two repeated factors? So in total, how many fractions do we need? Can you see how many fractions do we need? We're gonna need in total 5 fractions, right? So the first two fractions are working for this factor. So a over x minus 2 plus b over x minus 2 square, right? So these two fractions are working for this factor. And another 3 fractions, c over x plus 1 plus d over x plus 1 square and plus e over x plus 1 to the power of 3, right? So this is the pattern we should use when we have a rational expression like this.